All right, welcome to task 33, ratios. And it's the moment you've all been waiting for, the moment where I'm going to say, take out your calculator. You may now use it for the rest of the semester. But what you will quickly figure out is that although you have a calculator, it is a basic one, a 4-function calculator. And it is, yes, you have it, but you are smarter than your calculator, right? So you're not going to be able to just punch in a bunch of calculations, or you're not going to be able to rely on it to do a bunch of things that have order of operations in it. You're really going to want to use it for, quick calculations to check your work, or, to check like the multiplication or the division or the addition or the subtraction that you've relied on to do by hand in the previous half of the semester. There's still going to be a lot of fraction and decimal work that you still have to do. And most importantly, you're still going to have to really understand the processes behind what you're being asked to do. So let's get started and look at these ratios. So all a ratio is, when we're talking about a ratio, is a comparison of two or more things. And there's 3 ways we can write it. We can write it as a fraction, a over b. We can write it with a colon in between, a to b. Or we can write it actually with the word to, a to b. Now, with, we got into the conversation a little bit last week when we were reviewing for the midterm with fractions. Excuse me. Fraction order matters. So when you have 11 over 5, 5 over 11 is not the same thing. However, with ratios, no, it's not the same, but there are times where, 11 over 5 and 5 over 11, it's, you could be talking about the same scenario. It's just what you're looking at, like how you're looking at it. So, whereas that would be completely wrong with a fraction, it may be closer, or you might be on the right path with ratios. So let's look at again, why that might be, or how that might be, when that might come up. So for number 1, write the ratio 3 ways comparing part to part. So what are we talking about? Well, we can have parts and we can have wholes. Now, again, whole, we're talking about WHOLE, so like the entirety. We're not talking about hole in the ground. And, oh, sorry, I can't stop yawning all of a sudden. And when we're talking about that, so we're talking about like the total. So if there are 3 boys and 1 girl playing and we're comparing parts, first off, they have to tell us, like, we would want more information on this. So are we comparing boys to girls or girls to boys? So if we were comparing boys to girls, the 3 ways we could write that are 3 to 1, 3 to 1, or 3 to 1. Now, if we're comparing girls to boys, it would be 1 to 3, 1 to 3, 1 to 3. So again, the order, yes, it does matter, but it's going to be a variation of those numbers. with comparing a part to a whole with the 3 and the 1, the 3 boys and the 1 girl, there's going to be 2 scenarios. You're going to have the 3 boys and the 4 children, or you're going to have the 1 girl and the 4 children. Either way, your whole number is the same because you have 4 children playing. Now, writing the ratio in lowest terms, this is going to be the same as when you were simplifying your fraction. So the first thing you're going to want to do is write this in fraction form. And I'm going to take away the dollar signs for a minute because it just kind of convolutes things. And I'm going to use the method that we used during the review where I'm going to find a common factor. So I'm going to write 2 times 6 and 2 times 19 because I know they're both even numbers. Since the 2's are common, I'm going to cancel them out. And then I'm going to end up writing it back how it started. So what does this mean? Like, what does this ratio mean? Well, this means for every $6 iron, you earn $19. So say I'm selling something at a craft fair. Okay, I'm at a table, you're at a table. For every $6 iron, you earn 19. So while, if there's one item, that's maybe not a big difference. But say we both sell 10 items. Well, I earn $60, you earn $190. That's a big difference. That's a big discrepancy. So you see that, you see it there, what that actually looks like. Now, what about this next one? If I write it in terms of a fraction, I write 9 1/3 over 9 1/2 because, again, first one on top, second one on bottom. But now I can rewrite this as improper fractions. So I'm going to write 28 over 3 and 19 over 2. And now, what is that? That's really division of 2 fractions. Well, I did this last week. So again, here's an example where you have a calculator, great, but a calculator wouldn't have helped me for either of these, right? I'm not going to be able to plug either of these into my calculator, so I'm still stuck. So I'm going to take this one, I'm going to bring it up, flip it, and I'm going to get 28 over 3 times 2 over 19. Nothing simplifies or cancels corner to corner. So I get 56 over 57. Now, you see that when I'm comparing things, 9 1/3 to 9 1/2, that's not a great or an easy comparison to see. But if I say 56 to 57, that maybe is an easier one to visualize. So we can take it from mixed numbers, improper fractions, finagle it, manipulate it, and then we're, basically to a point where we're not looking at fractions at all. 56 to 57. All right, so now we're going to do it, but now we're in a little bit of a real world context. We have 6 pounds of sunflower seed to 8 pounds of sunflower seed. So again, we're comparing sunflower seed to sunflower seed. So I'm going to ignore the words for a minute and I'm going to just break down my numbers. So on top, I can write it as 2 times 3. On bottom, I can write it as 2 times 4. I have those 2's common, so I'm going to get rid of them. And now I can write it as 3 pounds of sunflower seed to 4 pounds of sunflower seed. So again, what does this mean? This means that if I have, for every 3 pounds of seed I have, my neighbor has 4 pounds. What does this mean on a bigger scale if I have a farm? Well, that means if I have a bunch of 3-pound piles of sunflower seed, my neighbor has 4-pound piles. Well, if I have 10 piles and my neighbor has 10 piles, every single pile has 1 more pound. So that's a lot more seed when you start talking on a bigger scale. Okay? Now, the next one we're going to look at, 10 minutes to 1 hour, we're comparing 2 different things. But, we don't want to compare two different things when we're reducing. So when we're reducing, we need to make it, we need to make it the same unit. So 10 minutes to 1 hour, okay, well, 10 minutes to 1 hour, can we make that so that it's the same? 10 minutes, how many minutes are in an hour? Well, we could rewrite that 60 minutes, right? 10 minutes compared to 60 minutes. We can cancel out those zeros, and now I can say 1 to 6, right? So basically, for every hour it takes you to do something, it only takes me 10 minutes. So it takes you 6 times as long as it takes me to do something. All right, a couple went out for the evening and spent $38 on dinner and $24 on the movie. What is the ratio of dollars spent on dinner to the total amount spent for the evening? Well, they didn't give us the total amount. So the first thing I'm going to do is I'm going to figure out the total amount. So the total amount was 38 on dinner and 24 at the movies. So again, even though I have my calculator, I'm opting not to use it right now. So my total is 62. So again, this is just like number 1, okay? It just has more words to it, but it's the same thing. So I'm comparing a part to a whole. All right? The part that I'm comparing is dinner to whole. Okay? So dinner was 38. Whole was 62. But again, depending on how I write it, I may have to simplify it. If I write it like this, I'm okay. But if I write it as a fraction, I have to simplify it. So if I write it like this, I need to simplify it. So I could write 2 times 19, 2 times 31. So 19 over 31 would be my ratio of dollars spent on dinner to the total amount. So for every $19 I spend on dinner, that goes into my total amount. $31 to my total amount. All right. So if we're writing now a rate, if we're thinking about a rate, what does that mean? Okay. Five cars for 20 people. We're essentially saying how many people go in each car, right? So how many people in each car? So if we want the cars to be, we want to simplify it so that the cars are simplified, right? So we want 20 over 5. Okay, and we want to simplify this. So again, we do what we did the other night. I can rewrite 20 as 5 times 4. I can rewrite 5 as 5 times 1. I get rid of the 5s. So I have 4 people in every one car. All right. 186 miles in 8 hours. And again, just jumping back, I don't really love the wording of that 5 people for 20, 5 cars for 20 people. If I were giving you the problem, I would probably write it 20 people in 5 cars, because again, you want cars to go on the bottom. All right. So again, I would give that to you so that the cars would be on the bottom and it would be in the right place. All right, so 186 miles in 8 hours. So we have the 186 in 8 hours. So we essentially want to know how many miles we went in 1 hour. How many miles can we go in 1 hour? Okay. And this becomes important like when you're talking about gas. Like in old days, when you had to plan out your trip and you had to figure out your mileage and where you were going to get gas and if you could make it from point A to point B, if there was, where are you going to stop and where are you going to get off in a rest stop, and there was no GPS and you had to follow your map in the car and you had to plan all that out ahead of time. This was important. So if we're simplifying this, I'm going to cut these in half. So 2 times 93, 2 times 4. The 2's cancel out. And I think that's actually all we can do. So I went 93 miles in 4 hours. All right, so 94 miles in 4 hours. Now, unit rate is a little bit different. How is it different? This is a unit rate. This is not a unit rate. Reason being, unit rates end with a 1 on the bottom. So in order to be a unit rate, you need a 1 on the bottom, okay? So if we do this here, we have 132 over 3, okay? So if we look for how this is going to work, and you have calculators now, I'm not using mine simply because I don't really have it in front of me. If I divide this, say I use my calculator, okay? I take 132 and I divide it by 3. I get 44. Okay, that's miles per 1 gallon of gas. Okay, because miles were on top and gallons were on bottom. So if I divide that, I get 44 miles per 1 gallon of gas. Okay, if I do the next one, 1,200 cars, 400 households. So I don't even have to do that in my calculator because you guys know the zero trick. So if I mark off those zeros and then do 12 divided by 4, 12 divided by 4 is 3. So 1,200 divided by 400 is 3 cars per 1 household. And again, why is it a unit rate? It's a unit rate because you end up with a 1 on the bottom. Okay. Find the actual cost of a gallon of gas if 16 gallons costs $63.36. So $63.36 goes on top, 16 goes on the bottom. And I get $3.96. So a gallon of gas costs $3.96. And you're all done. So let's look at a couple of the things that we really want to practice here. So writing our ratio in lowest terms. So 2 to 4. So we're going to write it as a fraction, and then we're going to simplify. So I can write 2 as 2 times 1. I can write 4 as 2 times 2. I'm going to get rid of the 2's, and I have 1 over 2. 3 to 12. I can write 3 as 3 times 1. I can write 12 as 3 times 4. I get rid of the 3's, and I am done with 1 over 4. Now, this one, I make sure you write the 35 on top. 35 is 7 times 5. 7 on bottom is 7 times 1. Get rid of the 7's, and I get 5 over 1. This is important because remember a ratio, a fraction, you'd get rid of bottom. Ratio, keep numerator and denominator. And the reason you do that is because in a ratio is a comparison of two numbers. If it's a comparison of two numbers, you have to have two numbers. So you have to have the numerator and you have to have the denominator. All right, for letter D, I'm going to write 15 as 5 times 3. I'm going to write 20 as 5 times 4. I can get rid of the 5's, and I end up with 3 over 4. 7 over 4, I can rewrite 7 as 7 times 1. I can rewrite 4 as 4 times 1 or 2 times 2. Neither of them simplify, and I'm just left with 7 over 4, sorry. All right, letter F, I can rewrite 8 as 2 times 4. I can rewrite 28 as 7 times 4. I get rid of the 4's, and I'm left with 2 over 7. All right, now practicing unit rate. So remember, unit rate, I end up with a 1 on the bottom. All right, so if I end up with a 1 on the bottom, remember, essentially I can get a decimal within a fraction. May get a decimal within a fraction. So this actually happens on this letter A of number 10. Because if you look, if I take 3 divided by 2, I get 1.5. Okay. Tablespoon per teaspoon. That's what that means. 1.5 tablespoon per teaspoon. So what this means is, like, if you're baking, it might be 1.5 tablespoons of olive oil per teaspoon of vinegar. Okay, does that make sense? All right, the next one, 135 pitches and per 45 strikes. So we're going to divide that out and we get 3. So 3 pitches per strike. $128 divided by 4, we get 32 miles per hour. Remember, per means divide, which is exactly what you're doing with that fraction bar. And that last one, 2250 divided by 18, we get 125 pencils per box. All right, and that's that. Practice, 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 and I will see you on our live.